This video will tell you everything you need to know about drawing pipes and cylinders, and it's in my book, Ellen's Guide to Perspective, where the Kindle is only $5. If the pipes are horizontal, as these are, then they converge toward vanishing points on eye level. This line is horizontal, so it converges toward a vanishing point on the right, and this one converges toward a vanishing point on the left. And notice that the minor axis of the ellipse lines up with the axis of the cylinder. These pipes look like they converge upward, but they're actually horizontal. What you have to do is find parts of the picture that we know are horizontal, like these areas, and then find their vanishing point. And when you do that, you could see that the pipes also converge toward that same vanishing point, so they are, in fact, horizontal. If we find the axes for each one of these ellipses and then extend them, we'll find that they meet at the center of vision. These pipes converge toward the center of vision, which is the beating of eye level and the central vertical line. If you scan across a bunch of pipes like this, an interesting thing happens. First, the minor axes of these ellipses converge toward what's called the nadir, and the major axes in white here form hyperbolas that go around like that. Now, where is the center of vision in all of this? Well, I took an uncropped photo here. And when you do that, the center of vision is in the center of the picture. So this is the center of vision. And then I connected all these minor axes and extended their lines down to the nadir, which is directly below the center of vision. And you can see also that parts of the shelf, like here, also converge toward the nadir. It's really just a lower vertical vanishing point. Pipes often have hexagons in perspective, and to find the hidden parts, draw the lines connecting the top and the bottom, as well as these lines connecting the sides. And then you'll see that these lines converge toward a vanishing point over here, and this part of the hexagon converges toward a vanishing point over here. Sometimes we need to connect cylinders. So in order to do that, we need to find this blue ellipse at the base of this green cylinder. And the minor axis of this ellipse is contiguous with the axis of the cylinder. We also need to find the circumference of the red cylinder that goes through the intersection of both cylinders. That's because if we just look at the ellipse itself, we see that it's composed of a right angle. But when we look at the cylinder as a whole, what we really see is the angle between the circumference of the red cylinder and the axis of the green one. In other words, we see this angle. Now, how do you find this intersection of two pipes? Well, find where the ends of the cylinder on top meet at the red dots, and then draw lines following the circumference of the lower pipe. And then we need a line across here at the base of this green line. And then you draw this ellipse in that space that you have drawn. And this is the final result. Now, some people put boxes in the cylinders, and I think that's confusing. You don't need all these lines. And also, it makes it difficult to draw this ellipse because the minor axis should go like this, and with the box, that's confusing. Now, pipes usually connect at right angles, so these are right angles in perspective. When you draw the actual lines on the top of the cylinder, it follows the plane at that point, not the ellipse. So the ellipse is properly positioned here where its minor axis is contiguous with the axis of the cylinder. But as you can see, the lines that we see on the top may converge toward the right vanishing point here, and this one is either horizontal or converging toward the left vanishing point. So the green and blue lines here form 90-degree angles in perspective, and they don't follow the two axes of the ellipse, which go like that. I want to show you how to attach cylinders to a sphere, and in order to do that, we need to get these elliptical holes. So the sphere looks like a circle, so its center remains constant, and any line from the center piercing the surface will pierce that surface at a 90-degree angle, as I show you here. So this is the minor axis of the ellipse, and the major axis is perpendicular to it. So as a result, as these ellipses go away from the central line, they have to tilt so their major axis remains perpendicular to their minor axis. And they remain between these two elliptical green ellipses, and their center lies on this blue horizontal ellipse. How do we find how wide the ellipses should be on a cylinder? In order to do that, we have to set up eye level and a measuring point on eye level and draw a line from that measuring point to one of the ellipses, as I did here. This line should go through the center of the ellipse, and it will touch it on the front side and the back side. And what you do then is draw three vertical lines from all of these intersections up to the other ellipses. And then when you want to find a new ellipse, you send another line from the measuring point to the area you want your ellipse to be in. And this ellipse has to touch, the back of it has to touch this line, the middle of it has to touch this line, and the front of it has to touch this line. So there's only one ellipse that would do that. Besides my book on perspective, I also have a book called Color, Light, and Shading. I have a book on casting shadows, and the art instruction course, which goes over the basic elements of art. They're all in Amazon.